And Steve, I'm gonna need your help to keep. All right. Again, thanks for letting me be here. My name is Chris Cilino. I work at DMC as a senior project engineer, and in this presentation, we're going to talk about something I've put together at DMC and applying to a lot of our different processes and procedures. I call it A.R.T.ful Engineering. We'll talk about what A.R.T.ful stands for and how it is related to security. It's kind of bigger than security. It's more or less how you do what you do. That having been said, here's what I hope to leave you with by the end of this 30-minute presentation. And Steve, I'm gonna need your help to keep me pressing along. Would you watch the clock for me? Like, dude, you're over time.
I will. Yes, I will.
Great. So I want to familiarize you all very quickly with DMC. I want to plant a seed that complying with a standard is more than just meeting requirements. It's a mindset. That is to say, if you have the mindset, then meeting the requirements or some sort of a standard becomes much easier because you're, already doing things, quote unquote, the right way. So we're going to talk very high level and somewhat nebulous. And then I want to go straight into some low level stuff. I'll talk about sharing some open source and free tooling that DMC has developed and is at your disposal. And I'll also want to show off, it's not open or available, but some examples of this artful mindset that has enabled DMC to achieve a couple of very well-known standards. And then, of course, we want to reach out and say, if there's any way that we can help you all, let us know. All right, a little bit about me. I actually started at NI in 2005, where I did lots of really cool stuff. I moved from NI to Cirrus Logic, where I turned Cirrus Logic into a LabVIEW Center of Excellence. If you're unfamiliar with the Center of Excellence program, it's phenomenal. I'm a LabVIEW champion, a certified LabVIEW architect. I've done consulting work, both with consultant companies like Compose Systems and now DMC. I also had my own consulting firm for a little bit, and I decided, we're good with that. So I moved over to DMC. Lastly, I founded the LabVIEW community's first, but not only, nonprofit organization called G-Central. So I'm very interested in using LabVIEW in the NI toolchain and seeing people be very successful with it. Okay, so what's cool is at DMC, I get to take my experience and bring it, add it to a great set of people with a whole bunch of additional experience. Like I said, I'm a CLA LabVIEW champion. At DMC, we also use TestStand and VeriStand heavily. We have a ton of different certifications. Side note, in the lower right-hand corner of a lot of slides are these QR codes, and it's designed to take you to things like DMC's website or vipm.io, where you can download some of these tools. Okay. DMC is broken up into 5 different service areas. Again, I'm going to go through this very quickly. We've got test and measurement. That's the one that we're mostly familiar with here in this in this group. But we do general application development across lots of different platforms, web, databases, of course, desktop. We have a whole entire automation department. Think all things PLCs, HMI, and SCADA. We do embedded development, and we have our own internal fabrication studio. Inside of test and measurement, this is just drilling down a little bit more. A lot of LabVIEW programming. We create automated test stands. We've specialized in EV battery pack test systems, real-time FPGA, et cetera, et cetera. All right, like I said, we have our own in-house fabrication studio, so we can do everything under one roof.
You're never going to make it general purpose.
So I'm hearing reverb or an echo.
Yeah, I'll find out who it is. I'll need it.
All right.
Here it is.
DMC has 15 different offices throughout the United States. I'm actually in Austin, Texas right now, and we have about 280, actually closer to 300 employees now. So we're distributed throughout the nation, which means we can visit customer sites in person pretty easily. And we get to work with a lot of different clients in a lot of different industries. That's aerospace, defense, automotive, chemical. So you can imagine standardization is really, really important to us. And one of the questions was asked earlier is, when do we justify ROI in putting together standards and complying with those standards? Well, oftentimes we don't necessarily have a choice. If we want the business we have to become compliant with standards. This is where having an artful mindset sets us up to already be compliant, or with minor tweaks, enables us to be compliant. These are some of the, we've worked with lots and lots of different companies, but with companies like this, like I said, you can imagine there's a fair amount of regulations that we have to comply with. And that gets us very close to where I want to start diving into more of what artful engineering means. DMC recently, that is to say about 18 months ago, won an opportunity with Northrop Grumman with NASA to work on the boosters for the new space launch system. Really, really cool. Well, as I'm sure you can imagine, there's a lot of requirements when we're putting together a test systems for boosters that are going to go on the side of the space launch system. NASA has an entire procedural requirement, 7150.2. Y'all may have heard of it. In version D, there's a whole entire segment on cybersecurity. But here's a super, super brief bulleted list on what does it take to become compliant with 7150.2. You have to put together processes for all your software management, software engineering lifecycle, support lifecycle, software documentation, and many dots. All right. Here's what I suggest. I'm going to make some assertions, plant some seeds, and see if you guys come along with me. In my research, I did some comparisons between NASA's 7150.2 and a number of other standards. And I asked ChatGPT and some of my other, again, research to do a comparison at a high level. Here's what I found. In general, at a very high level, most of the standards, and this would include things like cybersecurity, they have the same general notions. Planning, requirements, design, implementation, verification, configuration management. Whatever standard you're trying to comply with, you're going to have these different segments to it. Here's what I've found. Those bullet points, plus a couple of others, equals artful engineering, where artful stands for accountability, reliability, and traceability. And so what we're adopting at DMC are these three qualities in all aspects of engineering, whether it's the bookkeeping for our projects, whether it's putting together Gantt charts or tracking requirements, putting together designs, creating the code, you name it. We're all about accountability, reliability, and traceability in all of our processes. And that means with very minor tweaks, we're able to comply with a lot of standards. So it becomes a mindset. If you adopt the mindset, then you can become compliant. And as these different standards get rolled out for cybersecurity, having this artful mindset will make the cost in complying with or implementing these cybersecurity standards lower. It clearly doesn't eliminate them. And there's all of the internal tooling that you have to build and all that kind of great stuff. All right. So how does this accountability, reliability, and traceability actually manifest? Like, what are the outputs? I think there's two different facets to it. There's a culture of your development team. There's a culture of your company that you have to cultivate. And then there's tooling that you develop in order to become compliant. And what's pretty interesting, some of that tooling, we just actually saw an example of tooling. That's knock knock. Well, that might be one in a whole series of tools that you need to put in place and coordinate in order to achieve an overall standard. So what I want to concentrate on is tooling specifically, not necessarily the culture, but keeping two different audiences in mind. So the software developers and the architects, they're going to need some tooling to achieve artful engineering, and then software project managers, they're going to need tooling as well. And some of that tooling overlaps and some of it's very specific. This is where I like pausing and saying, as engineers, as project managers, we want to stay as close to the engineering and the project management as possible and leave all of the detail tracking and the keeping our systems up to date to automation, to something else. So we want tools that can be stitched together to make our lives as the engineers or as the project managers easier. And that's what I'm going to suggest. As project managers, we want to, whatever tools you choose, for tracking requirements or creating your designs or actually producing the thing itself, there's a couple of qualities that I'd recommend. So again, whatever tool chain you use, we want our lives to be easier. We want the tools to make our lives easier so we can keep close to the engineering while remaining compliant. Here are just a couple. I'm not going to read through this whole entire list, but here are just a couple of characteristics of the tools I would suggest you very carefully consider as you choose the tools for your organization. They should be easy to develop in. You should be able to compare versions of your work as you create revisions. It should be easy to collaborate. Security should be taken into account by your tools. Ownership and accountability should be inside of your tooling. So again, we can go through this entire list. Well, we don't have time. On the right-hand side is a whole smorgasbord, a whole cornucopia of tools that you might choose, whether it's Microsoft's toolchain, Atlassian's toolchain, the NI toolchain, Google Docs, whatever it is, you just want those tools to have these qualities. At DMC, we picked the following. We chose Monday.com, Atlassian's Confluence, and Microsoft SharePoint for our work tracking, our design, our file storage, and we've integrated those very tightly because they have great APIs. And of course, for our development, we use the NI toolchain, which includes Teststand, Veristand, NI Package Manager, and the community tooling surrounding the NI toolchain, like VI Package Manager, Karaya's for unit testing. And we've got Python, and for our source code control, we use GitLab, right? So what we've done is to take all of these individual tools and integrate them all together so that there's a seamless workflow for both project managers and developers, so that we keep the project managers and the engineers close to doing the engineering work and less about, ticking the various boxes for making sure that you keep stuff up to date, your documentation up to date. All right. Woo, we're going at a breakneck pace. So when I say workflow, here's one example of our workflow and how we use these different tools and stitch them together. So we're moving from this high-level notion of artfulness and this nebulous accountability, reliability, and traceability, and we're starting to go into some details here. Like, how do we achieve traceability? What do we need to be traceable in? All right, so Monday is our work management platform. It enables traceability, work tracking. We can create schedules and bills of materials, and we can input requirements and artifacts, blah, 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 blah. It's really great. An alternative is Atlassian's Jira. I'm a real fan of the Atlassian toolchain. However, Jira didn't have some of the capabilities that Monday does have, so that's the reason why we chose Monday. I am a huge Confluence advocate. Confluence is where we store all of our knowledge, all of our plans, decisions, documentation, and so much more. And so when we talk about workflow, one of the very first things that's going to happen, our clients are going to give us some statement of work, or they say that you have to comply with NASA 7150.2 or some cybersecurity standard. That gets put into our library of inputs. That document goes into SharePoint, and then we translate it into a Monday requirements traceability matrix. That requirements traceability matrix looks like this. So this is Monday, but there's one line item for each shall, should, will, or may statement. Okay, and then we have a summary. We've got the requirement definition. And then Monday lets us put additional information with that requirement, like what Scrum items will we generate so that that requirement can be met? What acceptance test plan items are we going to generate that tests the code that implements the requirement? What's the verification methodology? Now, this goes towards traceability, right? We're tracing this work through an entire chain from requirement to work to test. And that mindset, this linkage between those three elements helps us fall in line with 7150.2 almost instantly. Oh, but wait, there's more. Monday also lets us assign a unique ID to every requirement, and I can list the origin document from which that requirement came, including the detail, like where inside the document did that specific text come from? We can assign a client owner and the DMC owner. We can even mark whether or not it's safety critical. Safety critical is something that's inside of 7150.2. But we can add this metadata, as many columns as we want, pretty easily. And there's full traceability of activity. Any one of the values in any one of those columns maintains a history of when the value was changed, by whom, from which value to which value. And you get that out of the box. Okay, I'm sure that we've all struggled with keeping track of this sorts of information and history so that we can be accountable when somebody says, hey, why did you do that one thing over there? And I can say, oh, Chris on this date changed the value from this to this. That's the reason why we're doing it. Well, it turns out that that sort of traceability is also required for achieving a lot of different standards. So you get that traceability right out of the box. We didn't have to implement anything. And that goes towards choosing a tool that lends itself to this traceability, quote unquote, for free. All right, once all of the requirements are translated into this requirements traceability matrix, we start putting designs together that demonstrate how we're going to meet those requirements. So as developers are putting together these Confluence pages, and if you're not familiar with Confluence, it's no big deal. It's just like an online wiki, right? You can type into it, you put pictures in it, you can embed videos, all that kind of great stuff. Anyways, as our designers are creating designs that show how we're going to meet requirements, the designers put this specific text, requirement covered, next to the statement of saying this is what we're going to do to meet a requirement. And this is a link to the monday.com URL for this requirement. All right, now there's where some magic starts to happen. I've written an API. This is free, it's open source, it's under MIT license that allows you to programmatically control Confluence. I can do things like examine all pages in Confluence for the text requirement covered, look at the link, go to monday.com because Monday has a really great API, and I can get the unique ID for this requirement and add it to the text. God forbid I ask a developer to do that sort of bookkeeping. That's irritating. That's the kind of, yes, we need that information, but that's not what an engineer should be spending their time on, right? So I can do this programmatically. Furthermore, here's what's really cool. Let's say that that requirement was safety critical. I can programmatically put at the top of every design page this banner so that the developer that looks at this design and implements it knows, there's a safety critical requirement here, and that means you have to do some extra stuff. As a matter of fact, with my API, which again is free and open source, anybody can get their hands on it, I can surround each requirement designation with this iconography so that the implementer knows immediately, I'm going to be implementing a requirement that is safety critical. And you can even do stuff like programmatically put labels on a page. The whole entire point is we're making it easy for developers to understand what they're working on is safety critical. And there's a single source of truth where something is marked as safety critical. That's in the requirements traceability matrix. The APIs take that information, which is single sourced in the RTM, and propagate it throughout the rest of the system. That enables easy workflows. So that's requirements getting linked to designs. Because now what I can do is programmatically scour all of the pages, all of the designs, and match them against all of their requirements. So you can imagine hundreds of rows where this is the requirement that the client gave to us, or that this requirement is perhaps in 7150.2 or some other cybersecurity mandate or some other document. And here are the designs or processes or procedures where we say how we are going to meet this requirement. And this is all programmatically generated and kept up to date. You can imagine that as designs morph over time, we would not want to ask engineers to update this table manually. What a nightmare in bookkeeping that would be. So we programmatically generate this and keep it up to date, which also enables auditability. And that goes towards this traceability, right? Okay, and again, you can download the Confluence tool. It won't generate this out of the box. This is an internal tool that we have at DMC. But this sort of programmatic interaction is completely possible using the Confluence API. Oh, but wait, there's more. Inside of Confluence pages, we can programmatically generate documentation for things like classes or libraries. And this API auto documentation tool is also free and open source. You can download it. You can get it through VIPM.io. And it'll take, we programmatically examine a class and we pull out information like, what's the point of the class? What's all the private data and data types of the class? What are all the members and the descriptions and the prototypes? All programmatically generated and constantly kept up to date. Diving in on that just a little bit, this is again for, we're getting low level. What goes into some of this auto-generated documentation is the names of the private data in the class, the description of that private data, and even the data type. So for example, if you have a type def that is an enum, here are all the different values of the type of the enum that is type def. And even the name itself contains information. So you might have the name of the element in the cluster, perhaps it's a DVR, and that DVR might contain something else. The period means the thing inside of what's contained. And we also denote clusters and arrays. So just to drive the point home, here's what the private data looks like in LabVIEW. You might have a cluster named user configuration, squirrely bracket indicates cluster. Inside of it, you might have an array of paths. One of the elements inside of that array is a cluster named system cluster that has a name. Again, all programmatically generated. So I mentioned that this documentation, we take it from LabVIEW, and using this free and open source MIT licensed toolkit, which you can download, we can generate Confluence pages. And I've also made this so that you can generate that documentation into Bitbucket or GitHub or GitLab. If you generate it into Confluence, you can then turn it into PDFs and Word documents. Now, there's lots I could say on this. I actually gave a presentation at a LabVIEW Architects Summit meeting. This is the one that Alan Smith and some of the community members lead while I was at Cirrus Logic. And here's the video online. So if you want to see more information about this, see how to use the toolkit, there you go. Diving into a little bit, how did I do this? Well, I enabled something called VI scripting. And you can imagine, so first off, VI scripting is enabling LabVIEW to programmatically control itself. And that means you could write a VI that programmatically creates another VI or programmatically interrogates another VI for lots of information. You could imagine wanting to programmatically interrogate a class to find out what are all of its accessors that get information from a UI so that you could then perform cybersecurity tests on that UI. Like you input a string, are you range checking that string? Well, you can programmatically check, does your accessor have range checking inside of it, or is it just a dummy accessor? Anyways, the whole entire point is the LabVIEW IDE has a way to programmatically interact with itself, and you enable this by going to Options, VI Server, and then you check on VI Scripting. And when you do, you get a whole new series of palettes and functions. So you've got VI scripting inside of the application control. All of the VI scripting functions are in this blue color. So this is just an example. If you get a reference to a library, you can get the library's access scope, which is pretty cool. I'm going to show you an example of what you can do with this VI scripting. There's actually two VIs here. This background block diagram and this front diagram, this is one VI. And then this target VI, this is another completely separate VI. You might want to programmatically ask, what is the text of the comment on this page? How do you do that? So you get the name of the VI, open a reference to it. You use this traverse for geo objects, great. And then I know that the first element is this comment. I cast it to text, boop, there's the text of this comment. You can imagine putting like hashtag the requirement ID inside of this VI as a means of saying this VI meets a given requirement. There's lots of different help for VI scripting functionality out there. The LabVIEW wiki is an incredible resource. If you're not familiar with it or you've never been to it, you're missing out. So check out the LabVIEW wiki, search for VI scripting. There's lots of information on there beyond just VI scripting. This is the landing page. They talk about things like the different events in the community, all of the new information per release of LabVIEW, tons of great information. Okay, we got 6 minutes left. I'm going to really rush through this. So one of the common elements for all of these plans, whether it's 7150.2 or any of the other standards, is this notion of a configuration management plan. And that means taking a snapshot of your entire system, from the requirements to the documentation, to the designs, to the code, to the built artifacts like the version of the software, to a bill of materials of the hardware, to the versions of the software on that hardware. That is one entire snapshot. All right, well, how do you go about generating a version for a given piece of documentation, like an overall plan? This is a nice one. Because Atlassian has a great API that I've wrapped inside of LabVIEW functions, I was able to create an application. Oh, we're not going to have time to walk through this. That's fine. I'm going to demonstrate this just very, very quickly. Hope that this works. All of our configuration managed items inside of Confluence show up inside of this tool I created called the Confluence Configuration Item Release Tool. And each row is a configuration item with a unique ID and a title. It contains who the owner is, what the current version of that configuration managed item is, and what the next version is should you release it again. And to release it, you just hit the play button here. Here would be all of the versions, all the PDFs, all of the exports. As a developer, I don't care where in SharePoint these things are. I just need to get my hands on them. So CERT, the configuration or the Confluence Configuration Item Release Tool, maintains a list of all of the generated artifacts so that you can just double click on any one of these and it takes you right to where it's stored. Oh, I also list when it was exported and by whom and for what stage of the project. Again, this all goes to traceability for that A.R.T.ful Engineering. So I double click, great, here's my PDF. I can open it. And I'm keeping this information up to date programmatically. As I generate new releases, I'm not going to ask the developer to update the version on the landing page of this this artifact. That's ridiculous. Nor am I going to ask them to keep the release date up to. That should all be done programmatically, and the APIs enable you to do that. Furthermore, you're going to need to know what changed from version to version. Let's imagine that a developer comes in and is editing a design and they do some change to it and they add, like, I made some change. Sounds great. Okay, so this is Confluence. I'm showing you right now. CERT will go through and programmatically aggregate all of the changes across all of the pages from version to version and put them here. And this is what it looks like. This is the page that I just made an edit to. The most recent version is version 2, edited by me on this date with that note. Again, this goes to traceability. Right? And out of the box, Confluence gives you this ability to diff between versions. So I can see that anything that was highlighted in green shows up here. Like I added some change between version 1 and the current version, which is version 2. I didn't have to program that. That came out of the box. All right. So we've created this tooling, and we're all going to have to create tools that enable us to meet different requirements. Here's another example of a tool that we created. I'm going to blow through these last couple slides. So from beginning to end, we can bidirectionally link different elements of a project, from its requirements to the designs that meet those requirements, to the code that implements the designs, to the tests that test the code, with the results of those tests, all in a single view, including a summary up here. How many tests were run? How many tests passed? How many tests failed? And this is programmatically kept up to date continuously because we integrated all of our tools together using those APIs. Kevin Shirey, who's one of my fellow DMCers and fellow LabVIEW champions, has put together a number of tools. I can't go through them. They're all at GDevCon recordings, blah, blah, blah. Don't worry about it. All right. So this is the last thing. I've started to put together a series of blogs that talk through a lot of what I just shared with you all. There's 7 different blogs in the series that talk about how we apply artful design for implementing process and procedure that comply with various standards. Look at that. I got through with 1 minute to spare. If you guys would like to talk more, here's my contact information. A.R.T.ful Engineering. I'm very passionate about this. And that's all I have to say about that.